In this video, I'm going to explain the meaning and notation for limit of a function. This is part 1 in the Notes and Learning Goals for Lesson 2.1, Limits. All right, you see that we have some function data here, and we have two graphs. We have the graph of f of x equals x minus 1. We have the graph of g of x equals x squared minus 3x plus 2 over x minus 2. All right, so now what we're going to do is we're going to investigate what happens as x approaches 2. What happens to f of x as x approaches 2? What happens to g of x as x approaches 2? All right, now you'll notice that the two graphs look almost exactly the same. That's because they are. Both of these functions are basically the same function, except for g of x has what we call a hole at 2, 1. Basically what this means is that the point 2, 1 has been taken out. And in f of x equals x minus 1, it's put in. I've emphasized that with the dot. All right, so let's now investigate what happens as x approaches 2 from the left approaches 2 from the left, and what happens as x approaches 2 from the right. Okay, now notice what happens, right? As x approaches 2, both from the left and from the right, we can see graphically that f of x approaches 1. Approaches 1. Here we can see that as x approaches 2, f of x approaches 1. So as x approaches 2, f of x narrows in on 1. As x approaches 2, f of x narrows in on 1. Now you can see this from the data, right? As x approaches 2, f of x, x minus 1, approaches 1. But in this case, g of x, g of 2 is undefined. G of 2, if we were to plug 2 in there, you'd get 0 over 0. Okay? So g of 2 is an undefined number. But it doesn't matter. All right? With limits, we're not concerned. We're concerned with what we approach. Okay? So in each case, the limit is the same. The limit as x approaches 2, g of x here, I apologize, g of x there. As x approaches 2, g of x approaches 1. As x approaches 2, f of x approaches 1. So in both cases, we would say that the limit right, remember this is my f of x, this is my g of x, right? So as x narrows in on 2, f of x narrows in on 1. As x approaches 2, g of x narrows in on 1, even though 1 is undefined for our function. Okay, now let me show you one more thing. This polynomial x squared minus 3x plus 2 can be factored. Okay, this was my g of x. So now you can see why g of 2 is 2 minus 1. Put 2 in there, 2 minus 1, 2 minus 2, 2 minus 2, you get 0 over 0.